So this is the fourth lecture of our series like motion in a straight line. So let us understand first the concept of distance and displacement. So let us draw a random curve like this. So this is by school, right? So let us consider this as our school and consider the starting end, right? So this is our home, right? So this is a very common example of distance, right? So you may go from like home to school by taking any zigzag path, so that path will be known as distance, right? So distance can be any path, right? So there are infinite number of possibilities for going from home to school, right? There can be more than one path, but for the displacement, right, displacement will be always a straight line, right? So there exists a shortest path which is known as displacement, right? So this is known our displacement. So this is our shortest path. So how many possibilities of displacement are there? So there are only one possibilities for a displacement, right? For distance there are n number of possibilities, but for displacement there exists only one displacement. There exists a shortest path, right? So displacement can be a curved line, but distance can be a curved line, but our displacement will always be a straight line, right? So displacement. So let us write distance. Distance is nothing but this is our scalar quantity. So distance always remains a scalar quantity, right? And let us write about the displacement as well. So displacement is nothing but this is our vector quantity, right? So what are the properties of vector quantity? We have already studied, right? So a vector quantity both has magnitude and direction as well, right? They both have directions and magnitude, but for the scalar quantities such as distances, they have only magnitude, they don't have any directions, right? They only have magnitude, right? So we have understood this. Now let us look at the question. Suppose there was a man, right? Consider yourself, right? Consider yourself moving from P1 to P2, then P2 to P3, then P4 to P5 finally. So let us assume that P1 was your initial position and P5 was your final position, right? So this was your final position, right? So like in this way you have like from P1 to P2, P3 to P4, and ultimately you have reached a point which is your final position, that is P5. So your net displacement would be like this. This can be written as mod of P1 minus P2 plus mod of P2 minus P3 and so on. So your displacement can be written in the modulus, right? So basically displacement is nothing but final position minus initial position, right? So distance is always positive, but displacement can be negative or can be positive or can be zero as well, right? So now why displacement can be positive, negative or zero both? So let us understand with this example, because since what is displacement? Displacement is nothing but this is mathematically xf minus xi, means final position minus initial position, right? So let us write, if my xi means initial position is greater than the final position, then of course displacement can be negative, and if this happens to be equal, our displacement will be zero. And if x of f minus x of I is greater than 0, or in other way xf is greater than xi, then our displacement will be positive, right? So these are the cases of, actually there are three cases, but for the distance is always positive. Distance can also be zero as well, but distance cannot be negative. So let us write but distance covered cannot be negative, right, in any real life examples, right? Distance and displacement can be equal as well for some special cases, right? So let us read the very important example. Suppose Savita lives on her school. She cycles 2 km in 10 minutes to reach her school. She spent 5 minutes, take rest, and realizes that she has forgotten something. Then she returned home and again covered 2 kilometers in 10 minutes. So let us understand like which of the two graphs are correct, right? Whether both are correct or one of them correct or both of them are wrong. So this is the first graph. This is graph between distance and displacement. This is the graph between distance and time, distance versus time graph, right? So what she has done, what we need to assume in that, in this graph we have assumed 2 units to be equal to 1 kilometer, right? So suppose she has covered 2 kilometers, right, in 10 minutes. So our time will be 10 minutes. So let us assume that 2 units is equal to 1 kilometer. So on 2 units, the distance will be 1 kilometer, and on 4 units, our distance will be 2 kilometers, right? So this is our 2 kilometers. So in this way she has covered 2 kilometers of distance. Then in between she took a rest because she was thinking that she has spent 5 minutes of time in thinking that she has forgotten her copy. Then again she started moving, right, moving towards her home, right. So this is the distance, right. So again she covered a distance that is equal to 2 kilometers, right, in equal time interval, right, that is again 10 minutes, right. 2 units is equal to 10 minutes, right. So now we are understanding position versus time graph. So she started from initial, she took a rest in between, right, and now she will be returning to her home, right. So this is the position, right, and when she took rest her position will not change and it will remain constant, right, and she will be moving in this way, in this path, and this path represents that she has covered the equal distance but she has returned to its final position, right. So this was her home initially and this was, she started from home and she returned to home, right. So both of the graphs are correct, right. So both of the graphs are correct, right. So let us write both of them are correct in nature, right. This is our answer. Thank you so much.